I think we can just go ahead and get started. So, welcome everyone to today's Zeek webinar. And today our speaker is Dob, who is one of the security team group leads at ESnet, and he's going to present on automated Zeek builds and adventures with the management framework. So, welcome Dob, and take it away.
Great, thank you. I assume you can hear me okay?
Yes.
All right. So yeah, my name's Dop, or Michael Doppetti. Everyone just calls me Dop anyway. And let's kind of jump right into this on what we're doing with our automated Zeek builds, and then we'll kind of in the second half here we'll talk about some of the adventures I've been having with the management framework as well. So first, shout out to Vlad, who did a lot of this original Ansible work. And Gitlab CI stuff. Without his kind of base there, we wouldn't probably be able to do what we're doing now. So thanks to him, there's a AI generated image of what Vlad looks like. So for context, what is ESnet? ESnet is the Energy Sciences Network. We connect all of the DOE research labs together, peerings in the cloud, peerings with universities. And our mission is, high speed data transfer for open science, and connect those labs to the internet. And this is what the network kind of looked like in about 2016 with ESnet 5. So at that time, our Zeek footprint was 2 production Zeek clusters, one in each data center on each coast, and a handful of test systems. That was all managed by hand. We'd compile Zeek on the cluster nodes themselves. We'd install binary packages manually, either by hand or using the Zeek package manager. And then we'd manage all the scripts by hand. We'd make edits directly on the hosts. If we need to do it on the second cluster, we'd go make that same edit over there, and hopefully it stays in sync. So not too long ago, we were funded to build the next generation of the network, ESnet 6. And the footprint looks mostly the same, except it's cooler now because it's in dark mode. But the difference now is we run all of our own optical waves and everything as well. And we built a kind of a different management network. So now we have, with ESnet 6, 3 production Zeek clusters and roughly 37 standalone systems monitoring that management network. We call those MN Zeek nodes. Those nodes can't reach the internet directly, so that makes it difficult to, they can't just reach out and clone Zeek or clone a package out of the repo. They can't really use the package manager that well because they can't reach GitHub. But again, like now with 37 plus systems and a bunch more test systems, we can't manage all that by hand anymore. It just doesn't scale. And if we use the pre-built binaries, we'd still have to build all of our own plugins. So we'd have to either have all the build tools everywhere or still be building at least part of it. So might as well build the whole thing, right? So how does this work? So we use GitLab internally. That starts with essentially a fork or clone of upstream Zeek. And then for the 3 OSs that we currently have in use, we start by creating what we call like a builder container. It's just a build environment with the tools, dependencies, and the base OS. And we save that container for the next step, which is to actually download and compile Zeek. So for each of those 3 OSs, it builds Zeek and creates a GitLab artifact that we just package up as a Zeek tar file. We structure this in a way that each version of Zeek would be installed in its own directory. So instead of installing everything just in user local Zeek on top of each other, we install everything in user local Zeek versions / whatever the commit hash was for that version of Zeek. And then a live link points to that hash, and everything else kind of links to itself, with Etsy and logs being the only exceptions. We want all the new versions to log into the same place. So we only have to point to one spot. So after the building, we have that artifact, after step 2. The third is to build a new container. We don't want to use the builder for this since it has a bunch of extra tools. So we want to know what the minimum dependencies we need to actually install and run Zeek. So we build another container as a test environment, and then that uses the built tar file, executes it, and makes sure Zeek can execute properly. It's not looking at live traffic at this point. It's in the Gitlab CI environment, but that gives us a really good indication that things have worked, at least to this step. And when that works well, you can go into GitLab's build pipeline menu and see that, hey, everything is green check marks. These days, it takes maybe 45 minutes to an hour to get all these builds done and build all the containers. And it does this all the time in the background. Whenever someone, like I think every 5 minutes or so, it checks and sees that there's a new commit out in master. And if there is, we pull it down and build it. Common issues, code depreciation. Not really a problem with Zeek itself or anything. But it's just us ignoring code depreciation warnings long enough that it will eventually bite you. It will actually be removed, and you'll have to rearrange your code to get it to work. We've had some plugin code restructuring stuff where, like old plugins will have a different, configure or CMake environment. So the Zeek build will build fine, but then the plugin build fails, which kind of breaks the whole pipeline. And any real issues we find that aren't our fault, we feed those back to Zeek's testing team, and hopefully those things get fixed before the rest of the community really sees them in releases. And we've had quite a few things come up that we've been able to track down and get taken care of. Sometimes if the code's not too hard, I'm able to submit a merge request myself. That's not all that often, but I can do it. And then it's kind of nice when I submit that request, and then sometime in the evening I get an alert on my phone that it was merged and the pipeline is now fixed for master and everything's working. And I didn't do anything but just sit there and watch TV. So a recent example of something breaking, this is what it looks like, depending on where it fails. You can tell from this that, Zeek built fine. All the plugins built fine. Everything was hunky-dory. But then when Zeek tried to execute, it died, and on all three OSs. And if we look into that pipeline and what actually happened, we were actually getting a seg fault just running Zeek-H, dumping core. Usually, for me, I'm not as strong with containers as I am with real hardware, so I'll try to replicate that build failure on real hardware. This is easier for me, and it also improves. It wasn't some GitLab CI like running out of memory problem. So in the previous example, it would seg fault like we saw on the container, but it would just hang on real hardware. I ended up tracking that down as a conflict between a custom metrics plugin we were using and the work Tim was doing, changing the telemetry metrics in Zeek itself. So they're both I think they're both trying to listen on the same port or something like that, which oddly causes a seg fault on the container. So we just changed up our environment a little bit, and everything was good to go. So pros and cons. Obviously this was a lot of work to get set up the automated builds and deploy testing. But with all the different versions of Zeek installed, if something breaks, we can easily revert back to whichever commit hash version we want, and restart Zeek on that, and it'll work just fine. We also nowadays we rarely make changes on production systems. We'll make changes in GitLab and onto the scripts, or push something from Ansible, and we don't have to worry about logging into all 37 management nodes and doing something. Another nice benefit is when we don't always know ahead of time, but when the Zeek project announces a security bug or something, we either already have binaries built for that, or I can go look and they're currently being built, depending on how quickly they sent the email after merging it in. And then I guess probably the biggest benefit is by doing this, we do have those, we detect some failures and give feedback to the project when something isn't working. Disadvantages is all of those build artifacts take up a lot of disk space in GitLab. I get yelled at all the time about how can we delete some of these or do something to make that more minimal. So really, we've just set it to where if something's older than 3 or 6 months, we just get rid of it. It's unlikely that we're going to be rolling back that far. This also makes my job a little bit interrupt driven, and that if the Zeek pipeline fails, I pretty much try to stop what I'm doing and prioritize that over other work. Just to make, because obviously we need Zeek to be running, and if something happens, I want to be able to keep deploying it without running into this problem. And I don't want to let problems build up so that I have to fix them later. So we have Zeek, and we know it works on the 3 OSs. What do we do now? Now, what we also do is Zeek deploy testing. So we take on our Zeek test 1 node, every night it deploys whatever the latest master build was, and make sure it can deploy it out on real hardware. It starts up, it sees traffic, and everything is working just as it should be. And usually at this stage, if something is broken, it's not a Zeek issue, it's something else. One time it was, like I had mentioned here, is MaxMind changed their API on how to download the GeoIP stuff, and that was separate from Zeek. We were downloading those files, and that broke. So usually it's something along those lines, but still it helps our process. And this deploy testing is accomplished through 4 different Ansible roles. And I'll mention now, if anyone's interested in these, most of it I should be able to share as far as, if you need to steal our network capture stuff, I think we could be able to share that out, no problem. But the first one is the network capture role. And this copies over and runs a Python script that tries to gather a ton of information about, for our case, it's either Intel or Miracom NICs. So it attempts to figure out which is the active NIC, which is the active interface on that NIC. If it's Miracom, it'll rebuild and reinstall the driver. And then it'll create a systemd service file. So on reboot, it will automatically tune or retune that interface the way we expect it to be. And this is the nice thing about this role is it's completely reusable for more than just Zeek. So if we have a packet capture system or a Suricata or something like that, anything that uses a network capture interface, we can run this role and it'll do the same thing. As a side note, unfortunately, Miracom NICs are no longer supported, but we didn't know that when we purchased 37 of them and put them all across the country. The next is kind of the main heavy hitter role. This makes sure the Zeek user exists. It installs Zeek from our GitLab artifact we built automatically. It supports our different land Zeek and management net Zeek scripts. It accounts for differences on the OS, as far as dependencies go. And I'll get more into this later, but it also does things that zeekctl would normally do. So it will convert networks config and convert that to a local networks.zeek file, and it will manually or automatically create the cluster layout.zeek file that lets the cluster run. And then it sets up a bunch of systemd service files that run the cluster. And I'll talk about that a bit more in a bit. Finally, it sets up cron jobs for log cleanup and testing out our alerts, making sure things are working. The third thing is the Zeek Scram, which used to be Zeek BHR. This just creates a virtual Python 3 environment, installs the client-side scripts and modules for Zeek, installs the client for using Scram. And as of a couple months ago, we're completely off the old BHR code and on Scram. So that's nice to see. If anyone's interested in that project, please reach out. Finally, we have a role that's completely dedicated to Zeek scripts. So at this point, the systems have Zeek installed. They can capture on the interface. That's all working. But we have a different set of scripts we install depending on the environment. And these are all the custom scripts that we haven't gotten around to making a package for. Just little tweaks and stuff here and there, and any of our configuration for base scripts. Variable redefs, notice policies. What port should Prometheus be listening on, stuff like that is all handled by the Zeek scripts role. And this is what it looks like as a full picture. And again, we grab Zeek, build it automatically in Gitlab CI, and then at the click of a button in Ansible, that gets deployed out to all of our systems whenever we decide to do it. So typically speaking, we're running some version of master in production across everything. I don't deploy it like every single master version comes out, but once every couple of weeks or so, we'll push whatever the latest one is, and so far that's been working for us. No real problems. As far as the CI part of this talk, it's like I mentioned, it's a decent amount of work up front, but it is paying off. We've had more time to do real security work versus maintaining infrastructure. Another side benefit is like me or Fatima aren't always around, so if not everyone on the team has to be a Zeek expert to make things work. If something's broken, they should be able to just go into AAP, redeploy, and it'll fix itself. And that can be, it can even be a hardware failure. We had a situation where a pipe broke in Starlight and dumped water on our rack. It took a little while to get the new hardware there, but once it was plugged in, we just hit the button and it rolled out Zeek for us and got it all up and running. That was pretty great. And again, we use Zeek. This whole talk is about Zeek, obviously. We use that as the example, but we're trying to do the same automation process for testing and deployment of all of our security services as we have time to do it. We think that's a pretty good way to go. So again, huge thanks to Vlad and Sam also for helping me out with some of the Ansible stuff. So I mentioned a little bit about Zeek control and systemd, which is where we get into our adventures with the Zeek Management Framework. So these slides are mostly just a bunch of random stuff I've come across as I'm trying to get this to work. But you probably know that Zeek control was planned to be depreciated sometime in the Zeek version 7 timeframe. And the Zeek Management Framework has been available since Zeek 5. I don't know a whole lot of people that have been playing with it though. And kind of why I took a couple things from other people's slides, but Zeek control works pretty well. It's been working for years, but it's kind of an old method. Distributing binaries and scripts via SSH and rsync. Multi-node clusters, since it's distributing binaries, they all have to run the same OS to run those binaries. You have to have it all in sync, and there's not really any higher level process management. I'm sure some people still do, but I remember back in the day, you just have Zeek cron run to restart your workers every so often so they can recover from being crashed. And that's not, the most modern way to do things anymore. So with Zeek control going away, but management framework wasn't really well tested, we took a detour with systemd. This is kind of what I already talked about. It's deployed via Ansible. It builds all the logics necessary for a single node cluster. So let's say cluster running on one piece of hardware. But it also handles the process management for us with a systemd target that groups all the multiple services together. So it spins up all the workers, spins up the manager and the logger, and handles, starting those together, making sure they're running. And obviously, if the manager fails to start up, then it will downstream fail the whole service, and you have to go figure out why. The biggest drawbacks for sure is that again, I don't know anyone else actually doing this, so we're basically self-supporting. And we've found there's no really good way to run or monitor a multi-node cluster with the systemd method. So I started thinking, okay, well, we can do it. We can run it with systemd, but then we have to have some kind of messaging system to tell the the worker nodes what to do. And it's like, oh wait, duh, that's what the management framework is there to do. Let's start using that. Let's just try to use the management framework. And that can get us back to a place where we're doing the same thing the community should be doing eventually, and we can also contribute back to that effort in the process. So the management framework. I don't want to get in too much into details of this. This thing is it's extremely well documented on the website, and I think there've been a couple talks about it. But very briefly, as the components go, each system has a supervisor process. It's the thing that manages the Zeek processes, make sure that they're running. They also have an agent, and the agent is a thing that talks to the controller to tell the supervisor what worker nodes or manager nodes it has to start up. And then you also have one of those systems is going to be running a controller, and the controller is kind of as far as the brain goes, as far as telling the agents what to do. It's where you're going to do all of your tell it to deploy a config or get the node information, show you what the settings are. It's kind of the main point of communication for the whole thing. And then there's a tool called Python script called Zeek Client, which lets you interact with the controller. And those are kind of all the components separately. And the documentation shows what it would look like on an all-in-one system. If you're running on a single system, you'd have one supervisor, one agent, the controller, and all your worker nodes running all in one system. But that's not what we wanted to do. Our goal was multi-node clustering. So removing a lot of the lines and arrows, this is what we're doing. We have the 3 physical systems running workers on all of them. One of them also does the manager logger proxy stuff. So far, that seems to work just fine. Just having those on one of the systems. Each one has an agent, and on the one system has a controller on it. The controller really could be on any one of them, but it just kind of makes sense to me to have the controller on the one that is the actual Zeek manager. And the documentation shows, typically you're running this top line to start Zeek. It starts the supervisor, the controller, and the agent. We also add another small Zeek script for the management framework to help it figure out what it's supposed to talk to. One thing I forgot to mention is that we are transitioning to an IPv6 only environment. So getting but hosts will still have v4 addresses sometimes, and instead of preferring those, we want to prefer the v6 stuff. So it's just been easier to very clearly specify, what's the address you're supposed to listen on, and which, what IP is the manager going to be on, that kind of stuff. So this is what it looks like on the controller. You're telling where the controller is supposed to listen to. And then if you do the same thing for the other agents, instead of specifying the address, you're telling it where the controller is. And how to access it, and that works pretty well. Once we figured out those couple little variables, they communicate pretty much flawlessly as far as back and forth stuff. There's also the Zeek Client config. You can specify all this stuff, or at least the controller bits here on the command line. But I was getting tired of -- controller and port, so I just ended up. I've realized there was a Zeek Client config you can put in Etsy and handle all that for you. So that's been handy. So one thing to notice and be aware of when you start this up, if I start up, I have on each node, I started up the agents and the controller on the one, and I use get Zeek Client. I say Zeek Client get nodes. It shows the agent on the first test cluster and the controller on the first system, but then nothing else. Well, I've got other agents, what's going on? Why isn't it working? It doesn't know the other agents exist until you try to deploy a config. So it looks like, oh my God, nothing's working. Well, it's because it just doesn't know they exist yet. So if you do the deploy config, then your other instances are going to show up. And if you have workers and stuff specified, it'll give you feedback on whether those are starting up or are running. And this little 127 localhost here still really bugs me. I've been trying to figure out how to get rid of that and get it to use just v6. So a couple gotchas. Zeek Client is going to be your primary interface to the management framework as of today. It's got a bunch of different commands. You can do a git node, you can do a deploy config, but you can't clear your config. Christian was nice enough to give me this little handy job, which is basically just deploy a blank config. That's how you clear it. But it seems to me that we should probably build a simple clear config command. Shouldn't be too hard. And all that returns output in JSON, so it's really easy to parse and see what's going on. And so that works really well. There's some other gotchas. Some of them have been fixed since I started coming up with these slides for what was going to be presented at Zeek Week. Some of the stuff has been fixed, which is awesome. So IPv6 support was a little bit iffy. We made some changes to Zeek Client to get that a little bit better supported. If you specified CPU affinity in the config, the cluster config, that was ignored. That's been fixed now. I found out that Zeek Client wants Python 3.7, which is not the default on some of the older Red Hat 8 systems we have. I haven't gotten past that hurdle yet. Hopefully maybe do that next week. If you auto set the metrics ports for telemetry, it doesn't restart the numbering for each instance. So for us, it's a little strange, having different port numbers listening for metrics on each host. But right as I was submitting that pull request, I realized, oh wait, if you had multiple instances running on the same host, having all the ports the same won't work. So that pull request might need a little changing to see if it'll work out. The other thing is if you redeploy a config too soon after clearing it, the nodes can get a little unhappy. So I think what's happening is, you sent the command out through the controller to the agents. They acknowledge that, okay, I've got this new config, I'm going to work on that. But it takes time for the nodes supervisor to spin those nodes down and spin things back up. And it doesn't seem like there's a verification there's no verification step that's done and fully applied before it tries to spin up the new workers, and you end up with a conflict of old workers and new workers trying to listen to the same port, and things get a little bit upset. The other thing I've been struggling with a little bit is startup. So if you've got a fairly static setup with the cluster running a management framework, it will try to help you out by caching the config in this SQLite file. Obviously changed based on whatever your host name is. That's great. The problem with that is if you're like us and you're deploying a new version of Zeek all the time, or you want to start up something, change your cluster config, or make sure it starts up okay after a reboot, random power outage or something, there isn't really a way to tell the controller and agents that I want to start up with this specific startup config and ignore the old one. So that's something I've been playing with, just with putting in a script in systemd to clear the config before I load it, that kind of stuff. But it's just something that I think we can fix it, not too hard. Great things. I mean, I'm complaining about little gotchas and stuff, but so far the Zeek Management Framework's been awesome. The supervisor really does a good job of, if you kill a worker, it'll restart it. It manages all that really well. Another huge benefit is, we mentioned that with Zeek control pushing binaries, every cluster node has to be exactly the same. You don't have that anymore. You can, all your cluster members can be running on different hardware with different scripts. Even it doesn't really matter. It's really, really flexible. The other really good thing is it seems like it's still early. There's not a lot of people running it as far as I know. So if you have things that you would like to see, like I mentioned, startup, if you have opinions and get involved, that is awesome. And we'd love to hear feedback. So with that is it for today. I'm happy to answer any questions if people have them. You can enter them in the chat, or Fatima can unmute you. Otherwise, this is how to get a hold of me, usually on the Zeek Slack pretty regularly.
Awesome. Thank you so much, Dob. Are there any questions right now from the attendees for Dob? I think Christian has one, so I'm just going to unmute you, Christian.
Uh-oh.
No, I hope you can hear me. Dob, this is awesome. Thank you so much. I have thanked you many times for all of the stuff you're doing here in person, and I just wanted to take this opportunity to make sure I'm doing this in public too. Like I know that we call you Dob CI when you find stuff on master pretty much in real time, and this is super, super valuable for us too. So thank you a bunch for doing this. And regarding the management framework, yeah, I think you're right. Like you're probably one of the only people who has really sort of gone this deeply into the whole thing, and there too, just thank you for the feedback, because it's been super valuable, and it's, I think, strictly on me that's not been moving faster. So I'll promise to do better. And yeah, thanks a whole bunch. Like super cool work. Very much appreciate it.
My pleasure.
Awesome. Thanks, Christian. All right. I think I don't see any questions anymore, Dob. So, all right. So thank you so much again for giving this presentation. Really valuable knowledge there, and a lot of things to learn. So I myself learned quite a new things about the management framework in this presentation. So thank you again for taking out some time and giving us this amazing presentation.
No problem.
Thanks. A quick reminder, there is going to be a next webinar next week on Wednesday at 9 a.m. Pacific time. And that webinar is going to be presented by Aaron Scantlin from NERSC, and he will be presenting on how Zeek helps secure open science. So see you guys next time, next week for that webinar too. So thank you so much everyone for attending this webinar, and see you guys next time.